Hi, I'm Gleb Eastman. I'm Staff Security Strategist at Splunk. In this video, I'll show you step by step how to implement SIG-BAE link analysis visualization within Splunk Enterprise. If you haven't yet, please check Splunk blogs for Advanced Link Analysis Part 1 of my blog post where I introduce capabilities of SIG-BAE link analysis visualization. And then you can head to Splunk base where you can download the actual visualization application. So let's build this demo from scratch. We'll start with the instance of Splunk Enterprise and we'll go to Apps, Manage Apps, and we'll create new application. So we'll click a button Create App and let's call it Web Traffic. Web Traffic, folder name Web Traffic, version 1.00, visible yes, author me, a description web traffic analysis, and that's it. Click Save and create this application. Once application is created, we can go on it, and basically it's an empty application. It doesn't do anything yet. So first thing we need to do is to import dataset. For the dataset, I've chosen to use a web traffic clickstream dataset that been downloaded from Apache Web Server from one of the test servers. So it looks like this. There are a number of fields related to city, country, IP address of a source request, information about the users who are logged in or trying to log in. We also have information about the browsers users are using, such as HTTP user agent, accept language, and so on. So the dataset is pretty sizable. It's about 1.1 million events in total. So it's a good dataset to build upon. So next thing we need to do is to upload this dataset within this application. So we'll go to Settings, Add Data. I'll click on Upload button. And then navigate to the actual location of file. So here it is, webtraffic2.csv, and it's about 260 megabytes in length. And it's done. So we'll click Next button. And we see all the fields that Splunk found in this data set. There is plenty of fields. We're not going to change anything here, but what we're going to do is to save source type. We'll call it WebT, just to be short, and make sure that we select our application web traffic. So we'll click Next, and what we need to do is to create an index. We'll call it WebT as well. Make sure it's on behalf of the web traffic application. Click Save, and then click Review, and click Submit. Once this process finished, we can click Start Searching, and basically Splunk will kind of run some basic search here. So instead we can see what's inside of our data set, considering the fields we might be interested in. So I just crafted the search query. It's pretty simple. I chose some valuable fields for us. So in this case, it's a country, source IP, username tried. It's a username that a visitor is trying to log in, using to log in to the system. Logged in flag. 0 means user is not logged in. 1 would be when user is successfully logged on, and also some metrics about the traffic, browser user agent, as well as about the pages that visitor is trying to visit. So once we have all the data in, next step is we need to create a data model. SIG-BAE link analysis visualization uses accelerated data model to do its fast queries. So to do that, we go to Settings, Data Models. We will click on New Data Model, title, let's call it WebT, application web traffic, click Create. Then we will add dataset root event. We call it webT as well. Index equal to webT. Here, that's the name of index we created with our dataset. Click save and then add fields. Auto extracted, and I'll select sample 10,000 just to make sure every single field will make in our list. So here we need to create the fields of our interest that will go into the data model. So here's the fields. City, country, region, it's a source of traffic. Accept language is a metric of a browser. Bytes in, bytes out, it's how many bytes been transferred during the request. I also selected date, year, months, day, and hour, just if we need to visualize which days or hours generate excessive traffic, might be useful. HTTP content type and method, it's also a metric of a traffic. Information about IP addresses and subnet, logged in flag, status of a request, could be success or failure and something like that, and URI pass, that's a page user visited, and username tried, that's a username user might try to log in as. So once we pick the fields, we click save, and next we'll do edit permissions. To accelerate data model, we actually have to make it shareable, at least within the app. So I click read everyone, write admin, click save, and then I press edit acceleration, accelerate, and in this case we're kind of dealing with a static data set. I click all time and click save. So then I go back to all the data models. Just to clean it up, I click create it in the app, and here we'll monitor when the acceleration will finish building. So you might get back to this page, click a couple times on this update, eventually it will become 100%. Also to note, while data is building here, you can repeat the same exercise within Splunk Cloud. Options and maybe some many choices will be a little bit different, but you can create basic applications if you have permissions within Splunk Cloud, or you can create this application, just follow these steps on Splunk Enterprise and open a ticket to upload it to the cloud, and essentially it will work in a very similar manner. So we got 50% is ready, still building, so let's wait a bit more. And it's finally finished. To check our data model, we can run a simple query to see if it returns us any results. So we'll just go back to search page of our application and do query like this. tstats count from data model equal to webT. It's the name of our data model. So we'll just run this query and it returns a single value. Result is 1.18 million of results, which is much as our original data set. We can also run a little bit more complicated query like tstats count as events by source IP, HTTP method, and user agent, just to see what it will return. And by the way, this is type of queries that SigBay link analysis visualization will generate every time user click on nodes or interact with this tool. So it just like kind of shows what kind of data is being returned. By the way, I haven't covered to uploading and installing actual SigBay link analysis application. It's a pretty simple process. You just go to manage apps and click button install app from file, and basically click choose file, navigate to the downloaded file of link analysis visualization, and once it's installed you should see entry in this table like this, SigBay link analysis. So that shows that our application is installed and enabled here. So next step, what we want to do is to build the dashboard, because we pretty much have everything under the hood is ready for that. So it's a little bit unusual process to do it, kind of a little bit weird. So we need to create dummy query. So I'll do it, make results. This query doesn't do anything. And what we want to do is to click on visualization. And by default, you might have something else selected. But once you click on this tool to select proper visualization, you navigate to SigBay link analysis. It has this icon, and select it here. And we can configure it right on this page before saving it as a dashboard. So if you remember, I'll just paste the text here. We run SPL query before index equal to webT, and then table shows fields that we consider important for us. So these are almost all of these fields we're going to use within link analysis. So SigBay link analysis visualization, one of the settings is ask for the list of these fields that are important, but it also, what it does, it asks to separate this field with the pipe, not with space or comma. So I basically copied all these fields and separated them by pipe, and I just exclude the bytes in, we don't need it within link analysis. So I'll copy this thing and go to format and paste it in fields value. Now data model is WebT, if you remember. When we were creating it, we assigned this name WebT, and data set is WebT as well. And then the aggregate functions. So aggregate functions, that's the settings here. It's a list of aggregates that you want to be calculated for every single fields once it visualized. And this is pretty useful and important settings. So the aggregates that we're going to use are this. So let me copy it here as well. I just show you, it's a kind of part of SPL query. So count as events, some bytes as bytes in. Basically, I want to see the summary of all bandwidth that being consumed by every element of a traffic. And then distinct count of usernames being used by, say, IP address. That's important. And these aggregate functions also need to be separated by pipe. So I just copy this construct and then click on format and paste this into the aggregates. Also large size seam, so you can change some look and feel parameters here. So I just click on large, and that would be enough probably for now. I will click Save As, Dashboard Panel. I will call it Web Traffic Analysis, and share it in up and click Save. Let's click on View Dashboard and see what kind of dashboard we created, how it looks like. So once it's loaded, it looks like this. So it's correctly loaded. It shows all the fields we need. The only thing I want to make it bigger, a little bit bigger vertically. So I click on Edit and then kind of drag this bottom part of it so it will be bigger. And I like dark theme in this case. And then I press Save and then refresh. So that's pretty much it to building the application and dashboard. So now we can use it. Lots of interesting fields here. Remember aggregate functions we created. They are shown on top. So we used events, we created bytes in, and we created username. And they color coded in different colors. So first aggregate is events. It's total number of events where each node is listed, is present in the data set. And we can see there is like a little number above each node that shows 18.3K, 6K, and so on. And let's look to this logged in field. So logged in 1 means successful logins. And there is 1.1K, 1.1 thousand successful logins detected within this data set. So let's see what kind of data is there. So I click on this logged in equal to 1, and link analysis shows me all the results. So these are all the usernames that were successfully logged on. I can hover on each of them and see where people are coming from. So I see quite a few people coming from United States. I see a couple logged in coming from UK, Canada, Panama, and so on. So that's good information right away. Now, there's little icons I can use to navigate, to control this visualization. So in this case, I press reset. By the way, if you click on this icon with a little keyboard icon, you can see all the keyboard shortcuts available here. One of the interesting functions that we used is bytes in, total bandwidth. So what we can do, you see these little icons, it's a sorting icons. And so let's say I decided to sort by bytes in descending order. And once I click this icon, every single column will be sorted by the bytes in, not by events, but now by bytes in. So what it shows me, now I can see each element that consumes the biggest bandwidth in my server. So for example, I see, okay, China consumed 14.2 gigabytes of traffic versus then second highest is United States, only 270 megabytes and so on. And if I go to IP addresses, I can see that this single IP address consumed 4.2 gigabytes of traffic. And number 6 means it only generated 6 events. So this is kind of weird thing, which I might to look deeper into. It's like part of investigation. So if you notice any suspicious excessive number or any kind of details you want to look deeper, you just click on this node and it will show you all the relevant related nodes here. So I see that this IP address coming from China, and there is no usernames, no successful logins within this source of traffic. And I see what's kind of browser user agent being used by this traffic, and I see which page being accessed. So it's really suspicious. Little number of events consume gigantic amount of traffic coming from China. What could possibly go wrong, right? You can also notice like suspicious, HTTP method, not get and post, but like prop find. You can click on this node, just trying to investigate where this stuff is coming from. And link analysis shows you all the relevant connections. By the way, this the absence of lines here, it's a little bugs that are being fixed by SigBay already. It means that one of this username tried was actually empty string. And when it's empty string, it's kind of like, it doesn't draw the nodes, but it was fixed in the latest release. So make sure you download the latest version. But again, so for prop find, it's kind of erratic traffic. Look at this user agent web-dev client. And then traffic is coming from Canada, Germany, Brazil, Bolivia, France, and so on. So this is like some sort of scripted traffic, not humans coming to our web server. And then you can click on user agent, you can click on pages, see who is accessing certain page most frequently, where traffic is coming from, who is logged in successfully, which traffic sends most failed logins. And there is lots of interesting information available within this link analysis visualization. You can click and hold Control key, and you can scroll vertically and horizontally to see more data. So please see first part 1 of our blog post on the Splunk blogs to get introduced to this visualization. And also there will be following part 3 of this blog post, where I will introduce really exciting feature that probably none other visualization on the market has. This visualization will include this feature. It will be super helpful, especially for users or data set with gigantic amount of data. So stay tuned, and I'll publish this update pretty soon. It will be published as part 3 of this series. So hope you found it useful. The data set will be available for you to download. The same data set I use for this application. The link will be posted in blog. And feel free to ask me any questions and contact me on my profile. Thank you very much and have a great day.